we want to be able to take this and make it look like this without using Cheater's method, without, I guess I'd just be calling it, educated ways to get around it. We want to be able to do it the real, true algebraic way and make that happen. It is and it isn't, because here's the key to it, Abby. Right there. And it's a connection to something we've already done, which is factoring. And if we can get something to be a perfect square trinomial and change it by factoring it into a binomial squared, then we will have this in vertex form. And the cool thing about the process that we're talking about today is that it will solve any quadratic. Absolutely any quadratic can be solved by completing the square. We were doing stuff by factoring before where we had to say, oops, that's not factorable, I can't keep going. With this method, we can keep going and we can figure out what the vertex form will be. So this is a process called completing the square. And like it says, our objective eventually, we're probably not going to get, we'll get some pieces of it today, but we won't go through the whole thing. Solve equations by completing the square. So we won't get to rewriting our functions until probably tomorrow. So warm up. Interesting. By factoring. We're supposed to warm up by factoring. So stuff we know about factoring is going to help us with this new objective. All right. Any factoring problem, we start by greatest common factor. Is there anything we can pull on all three of those? No. Okay. Next thing we check for is perfect squares. Is that maybe a perfect square trinomial? Yeah, let's check it out. That's x squared. That's 4 squared. And how do you test the middle term again? Multiply that result by 2. 4 times x is 4x. 4x times 2 is 8x. Okay, that's a perfect square trinomial. That means we can write it as something squared. Cool. What's the something? X plus 4. Now, why is that helpful? Well, let me ask you this. Do you know how to solve that? Without factoring, can you solve that? What do? Take the square root of both sides. And whenever we do that, we have to do the plus or minus. So let's just say something like this works out like this. Should we write x minus 3 times x minus 3, do the FOIL, move everything over and factor it? No. How do you get rid of squaring something? Square root. X minus 3 equals plus or minus 4, and away we go. And we can solve it from there. So part of the completing the square process is going to be, we can solve equations. But part of it is also going to be putting things into vertex form. So that's not done, by the way, but I just wanted to show you where all of this is going to go. X squared minus 6x plus 9. Can we pull something out of all of that? Possible perfect square trinomial? It is. You already checked it. Okay, but wait a minute. 3 times x doubled is 6x, not negative 6x. You remember way back when you guys brought that up to my attention the first time we were doing these? You said, well, that's not right because that won't be a positive 6x. And before long, you said, big deal. Just put the negative in there. Yeah, that's what we do. It doesn't matter if it's positive or negative until we get to this point where we're trying to write in that sign in between there. C. That's a lot of numbers. There's got to be something we can take out of all of that. Is there? No. Is it a perfect square trinomial? 2x squared, 5 squared, 2x times 5 times 2. 10x times 2 is 20x. There it is. So what should we put in there? Yeah, 2x plus 5. Going right in here. So this is the first step in a really important process, is figuring out, hey, I've got a perfect square trinomial here. I can write that as something squared, because then I can take the square root and I can get two equations equations out of this. X minus 3 equals negative 4, and x minus 3 equals positive 4. All I have to do is add 3, and I've got it. So my two answers would be negative 1 and 7. So step by step, we're going to get there. We'll get to that piece. These are taking us back to where we're just solving. So it says solving by finding square roots. What is the solution of each equation? And initially you might look at this and say, okay, I'll get a 0 on one side and then I'll factor it. Well, that's one way to do it. But I'm looking at this and I notice something's missing. Even if I move all of that over to one side, I'm not going to have 3 terms, am I? I won't have a middle term. There's not going to be one sitting here with just an x. And when that happens, it's much faster to just get x by itself and solve. So all we would do is subtract 10 from both sides, divide by 4, and then say to get rid of squaring something, use square root. So whenever you physically write that square root symbol down, be thinking, I'm going to need a plus or a minus here. If I physically write down a square root symbol, I need the plus or minus. Super easy to check. All we have to do is come up here and say, 3 squared is 9, 4 times 9 is 36, 36 plus 10 is 46, and it doesn't matter if I put negative 3 in here. When you square it, it's still going to be positive. So both of them work. Faster than factoring. Let's go to B. What should the first step be? Add 5 both sides. Then divide by 3. Then what do we do? Square root. Uh-oh, that's not a nice one. Well, I still have to write it. It's a positive square root of 10 and a negative square root of 10. Totally checkable. You go up here and you say, if I put square root of 10 in here and I square it, I'm going to get 10. 3 times 10 is 30. 30 minus 5 is 25. It doesn't matter that it has a negative. If it's going to be squared, it'll become positive. So there it is. And since lots of you have already done these two already, why don't you go ahead and finish them up and then check it with the chicken wing elbow partner. Make sure the person next to you is getting the same thing. There were just a couple of people that maybe did a little bit of math wrong. You know, you add the 10 to both sides, divide by 7, take the square roots, and you have to remember the plus or minus. If anybody misses this on a test, usually it's you forget the plus or minus. You know, you just have to remember every time you physically write a square root symbol down, that has to happen. So we isolate the variable. We add or subtract any number that's not with the square term. Move it over to the other side, divide by whatever's in front of it, take the square root, and we make sure we put the plus or minus on there. So this is a pretty fast and easy way to solve, right? We would really like to be able to use that for just about anything, and you can. Obviously, it gets a little more complicated. So now what we need to do is see, okay, what if it has a middle term? Can I still make this work? And the answer is absolutely, and we're going to do this in baby steps. So this is already set up super nice for us. They're making sure that we have a perfect square trinomial to start this process with so that we know what they're supposed to look like. So we see the problem right here, and we think, well, I can't pull a 4 out of all of that or anything else. So this is something squared, and this is something squared, and oh yeah, that is a perfect square trinomial. And we write it as x plus 2, the quantity squared, equals 25. But now we want to solve for x. And it doesn't make any sense to write x plus 2 times x plus 2 and multiply it out, because we'll just get right back to the step we just had. So what we have to do in order to gain access to this x is get rid of the parentheses. Well, the squared is what the parentheses are for. So how do you get rid of squaring something, everybody? Square root. So this is going to say x plus 2 equals plus or minus 5. Well, that's really two equations then. It's x plus 2 equals negative 5, and x plus 2 equals positive 5. Now, that order is important. To those of you that are going to go on to college algebra or pre-calculus next year, remember that we always order these with the number line. So it's like your elementary teacher probably had a number line in the front of the classroom with the 0 right up there, all the negatives there, all the positives there. We always make our equations setting up with that number line. So anything negative goes on the left, positive goes on the right. And that's the reason it's this way. I'm not going to take points off on your test for Algebra 2 if you don't do that, but know that that's an important step as you get to college algebra and pre-calculus. So we'd subtract 2 all over the place. And negative 5 minus 2 would give us negative 7. And 5 minus 2 would give us 3. Very easy to check. I mean, we've got calculators for goodness sake. We come up here, slap a negative 7 in here with parentheses, and in here, let the calculator tell us it's 25. Put a 3 in here, put the 3 in here, let the calculator tell us it's 25, and we're good to go. So totally checkable. Because this was a perfect square trinomial. That's what we want to make happen. So take a look at this one. Obviously, we can't pull something out. Some of you have already checked. Is that a perfect square trinomial? It is, isn't it? So what goes in the parentheses? X minus 7. And then what's your next step? Square root. So x minus 7 equals plus or minus 5. And what do you do with that? I know you're already doing it because your heads are down. Yeah, you set up your two equations. And then we add 7 all over the place. So we get a 2 and a 12. There it is. Again, checkable. Back, put it up in the original, make sure it gives you the 25 on the other side. Now, that seemed a little too easy. And it is because they set up the problems for us. They made sure we had a perfect square trinomial on one side so that they could say, here, check this out. Get used to it. But what if it's not? What if we only get the first two terms and we have to figure out what number needs to go in the last position to make it a perfect square trinomial? Well, we're going to come back to this one. We're going to talk about this, completing the square. So I think 2 pages you've got to go there. We're skipping the visual because I don't want to confuse anybody with the visual right now. We'll talk about that one tomorrow. And we're going to this header where it says completing the square. If that last number doesn't work, is not a perfect square. What do we do? That's the question. So what we'll eventually learn to do is move the 18 out of the way and come up with a number that will go there and will make it a perfect square. To do that, we just need to memorize a itty bitty little formula, teeny little formula. And that is, if you have x squared plus bx and you want that number that's going to complete the square, you're going to add b over 2 squared. That's the number that will complete the square. How are we supposed to know what b is? What's b in this one? How'd you know that? Ax squared plus bx. So let's just try this out. 4 divided by 2 is what? Squared. They're saying that would make that a perfect square trinomial. Absolutely it would. This is x squared, this is 2 squared, 2 times x doubled is 4x. That's the number that'll make it happen. So very, very small little formula to memorize so that we know how to get that last number to work. So this one says, how about if we gave you x squared minus 10x? What's b in that? Careful. Negative 10. So if that's b, we're supposed to take negative 10 divided by 2 and then square it. What's negative 10 divided by 2? Negative 5. And what happens if you square negative 5? What do you get? It will be 25. Makes sense. Put that plus 25 up there. We think, well, this is x squared, this is 5 squared, 5x double, 10x. There it is. That would make it a perfect square trinomial. This one, x squared plus 6x. What's b? 6. b over 2 squared is 6 over 2 squared. What's 6 over 2? 3. What's 3 squared? 9. That's the number that we're doing. Right back there. Now, those were very, very nice. Because our b values were always even, which means they all divide by 2 very nicely. What happens if they don't divide by 2 very nicely? Well, it's a little bit of fraction work. It's not a lot. So what's our b in this one? Yeah, see, there's the problem right there. Negative 5 divided by 2 is just going to be negative 5 divided by 2. That's not a big deal. Because if this is pure division or pure multiplication in here, that means we can just split this up and distribute that 2 and make it negative 5 squared over 2 squared. That's one of our properties that we have for powers. And you guys already told me negative 5 squared is 25. What's 2 squared? There it is. That's the number that will complete the square. Now, is it a little nastier? Yes. But you know what? Because of the math we're going to do after that, it ends up being really helpful that those will be perfect squares when we get done. So, things from today that we needed to be able to do were complete the square. We're not totally there. We're doing the baby steps. So, you've got one little formula you have to memorize. What's the one little formula? B over 2 squared. Okay, I'm going to ask you about that in a bit. Now, back up to this review problem. I want to make sure we're not going to forget how to do quadratics. We did this on the test. Show all work, graph. Y equals 2x squared minus 8x plus 3. Help me out. How do you start? Just took the test. So you're all using the stare at it and hope it goes away method again. It's still there. What's an important point that we've been looking for on our quadratic graph? The vertex. So there was a little formula that we needed to find the x-coordinate of the vertex. What was that? X equals negative b over 2a. So we look at this and say this is y equals ax squared plus bx plus c, just like we were doing a minute ago. And we realize, well, that's going to be the negative of negative 8, which is 8, over 2 times 2, which is 8, divided by 4, which is 2. So 2 something. So I go over here, and I put on my axis of symmetry, and x equals 2. The something. It's 2 something. What do we get? Plug it in. This goes here and here. So y equals 2 times 2 squared minus 8 times 2 plus 3. Well, 2 squared is 4. 4 times 2 is 8. 8 minus 16 plus 3. 16, yep, negative 8 plus 3 is negative 5. So our vertex is at 2, negative 5. 1, 2, 3, 4, 5. Well, that's not a parabola. It's a dot on a dashed line. I hope we have one like super easy point that we could find, so we don't have to make a table. Is there a super easy point to find? Zero, 3. Always 0, C. So 0, 1, 2, 3, use symmetry, equal but opposite on the other side. If this is just homework or a quiz or something, that's enough. We wouldn't need any other points. We just go ahead and make our nice little parabola. Right there, using symmetry. So the formula for this one, for finding that x-coordinate of the vertex was negative b over 2a. What's the formula for completing the square? Get it louder. What's the formula for completing the square?
B over 2 squared.
Good. B over 2 squared. That's the one you're going to use for today's homework, which I'm going to uncover in a second because I want you to 4, 3, 2, 1, 0 me on how you feel about using the B over 2 squared. Where's your confidence level at? All right. Not bad at all. So there you go. And these go very quickly, but the risk with that is always that you go too fast and you make a mistake. So kind of help yourself slow down a little bit as you go through those. And 90, 96, and 100 are just review problems. There's a factoring one. Yes. Completing the square.
Is there a non-1A? An A that's not 1 yet?
Not yet.
Okay, good.
No.
It's okay.
Don't you back out on me again.
Sorry.
All right.